Hello, physics. Static equilibrium. Find the masses of the objects A, C, D, and the mass of B is given, which is 0.885 kg. So D, C, B, A. So this mass is given, and we have to find out other masses where they are in equilibrium, and the arms are also given. So first of all, consider this 1, 2, and 3. So first, consider this as CD. So this one, so this is D, and this is C, and this is XC, and this one is XD, and this one is FCD, and this is downward force, which is MDG, and downward force is mcg. So if this is a equilibrium, then the sum of the torque is equal to 0. So if you're taking the pivot at this point, so there's no contribution of this one. So, and this is counterclockwise, and this is clockwise. So this one is positive, and this one is negative. So mdg into xd minus mcg into xc is equal to 0. So we can find out the m of d is equal to m of c, gg cancel, xc over xd. xc and xd as given, which is 5 and 17. X or we can find out right down in the form of m of xc, mc, which is equal to m of d into x of d into x of c, which is equal to 17.5 divided by 5 into m of d. So from this one, we can conclude that m of c, which is equal to 3.50 m of d. So this is equation 1. This is 1. So if we write down MA, MB, MC, MD, this is given, and we have found this MC relationship, and then we will find out this one. So number 2 is apply Newton's law. So Newton's second law on this one. So sum of the all Fy forces equal to 0. So now can find out FCD is on positive, which is equal to mdg plus mcg. But we have a this equation this applying this one. So mdg plus 3.5 mdg, which is equal to FCD, which is equal to 4.50 mdg. So this is equation number 2. So we have found the FCD force as well. Now consider the 2, bar 2. So this is bar 1. Now consider bar 2. So bar 2 is this one is uh, this force. So F, uh, this is DC and B. And this one is F of CD. And this one is MBG. Now this is in equilibrium. If it's in equilibrium, then the sum of the torque is equal to 0. If torque is equal to 0, this is torque here pivot is this one. So this contribution is 0. So this one, this is positive, and this one is negative. So FCD into this one, XCD, so is minus MBG into this is X of B is equal to 0. This is XB, X of B, and this is equal to X of CD. So from here, F of CD, which is equal to MBG into X of B over X of CD. So all information are here. MB is given, which is point this one. G is given, XB is given, XCD is given. So we can find out the and this one is also given from this equation, and this is equal to 4.50 mdg. So md, we can find out md, which is equal to, so g cancel. So this one is equal to mb xb over xcd into divided by 1 over 4.50. So if we substitute the values, then we can find out the m of d, which is equal to 0.0655, or which is equal to 6.56 into 10 power minus 2 kg. If we find this one, if we substitute in equation 1, this one, then MC is equal to 3.5 into MD. MD is this one, 0.0655. So this will give us 2.29 into 10 power minus 1 kg, which is equal to mc. So mc is also known, md is also known. So now use a bar. This is bar 2, now bar 1. So bar 1, so this is f of bcd, and this one is mag. This is x of bcd. This is x of a, and this one is f of abcd. So equilibrium, sum the torque is equal to 0. Pivot is this one, and contribution 0. This is this positive, this negative. So mag into xa minus fbcd into x of bcd is equal to 0. So from here, ma is equal to f of bcd x of bcd over gxa. So from here, f of bcd this is one equation. This is equation 2, 1, 2. This is 3. And then other one, sum of the all forces is equal to 0. So this one, f of a, now from here, we can apply the bar 2. So bar 2, so fy is equal to 0. From here, f of cd plus mbg is equal to f of dcb. So this force will come here, and then we apply this one ma. So still not this one. Ma is equal to the sum of f of cd plus mbg into this one x of bcd into g of xa, as xm of fcd is fcd is this one, equation 2. This is equation 2. Equation 2 is this one. So this is 4.5 into mdg plus mbg over gxa into xbcd, and if you substitute the value of m, all these values, then you got ma, which is equal to 2.94 into 10 power minus 1 kg. So mb is known, md is known, mc is known, ma is known. So all these components are now known. So this is all this question is done. So this is the question, and this is the answer of a slightly complicated question. So we have to use the bars. First bar is this one, then bar 2, then bar 3. When you bar, consider bar 1. So consider DC, and equilibrium tau is equal to 0. This positive and negative, you have MC. MC is equal to D into this arms. So substitute the value. Then we have from the equation 1, MC is equal to 3.5 into MD. And then use the second Newton's law. Then you can find out the up force is equal to down force, and MCD. FCD is equal to this one. This is equation 2. Then bar comes 2. If you consider bar 2, then we have this relationship. So this tau, and then you can do this one all calculation. Everything is done.